Grub Project, Gravity Assisted Pulse Motor 2-stage oscillator configuration update. Made some modifications to the pulse motor. We had to add a oak shaft because the metal one was applying too much load to the pulse motor, due to the magnetic attraction to the metal shaft. So, it seems to work a little better. As soon as we stuck a load on it, on the pulse motor, the RPM went way down. You could see that. So, whether or not this is going fast enough to do what we actually want to do is, it'll have to be determined. So the idea is we'll put a one-way bearing with a small weight on it, and as it spins around, we'll try to get the device to oscillate, and that'll provide power to the PMA. We may have to go to the old setup with the windshield wiper motor, and we'll add a pulse width modulator DC motor controller to it to minimize the amount of electricity it uses at the input. There are some problems with the pulse motor, and if I can get over there, we'll explain what's going on. Basically, what I found out is if the pulse is too long, it destroys the MOSFET. So I'm not exactly sure what's going on there. What was the other thing? Oh, we received a suggestion about adding a diode across the electromagnet. When I do that, it slows the RPM. So it doesn't seem like a favorable condition for this configuration. I think what's happening with the back EMF is I think it just goes back into the battery. So I don't think it requires a diode. And then what was the other thing? Oh yeah, we stuck just a modified heats alligator clips for heat sink, and it doesn't really seem to help. As soon as we stick any kind of load on the device, oh, this time it's working. Oh, okay. So we stick a load on it, and we just fried the FET. So, yeah. So as soon as any load gets placed on it, I think, the on time becomes too long, and, oh, wait a minute, now it's working. What's going on here? Okay, well, anyways, so we ordered, much better MOSFETs, and as soon as they arrive, we'll, do up the circuit with a proper heat sink, and that'll allow us, an increased on time, so issues shouldn't be a problem with the switching FET. What was the other thing? We have a 10K resistor between gate and source to, I think it helps. I'm not really sure about this, but I think it helps discharge the internal capacitance of the MOSFET, and it also supplies the a 12-volt on signal for the MOSFET, so it switches on. I'm not really sure if there's problems there or not. I don't have a lot of experience with MOSFET circuits, and so this whole thing is a learning experience. Well, yeah, see, when you put a load on it, I guess conditions change. Oop. See if we can get this working again. Oh, I just damaged the contact switch. Alright, so the contact switch is obviously a source of problems. We'll be going solid state with that as soon as possible. Yeah. Oh, yeah, and then this switches down. Yeah, okay, so identified another problem area is the contact switch has got to go. We have to go to some solid state configuration. There we've ordered magnetic proximity switches, so that'll be changed as well. So at this point we're waiting for parts and identified a whole bunch of new problem areas. Okay. But so we do have, if the pulse motor idea fails, there's a backup with the windshield wiper motor, and obviously once we get the this keeps, the switch keeps messing up. Anyway, so if this configuration turns out to be a failure with the pulse motor, we can go with the windshield wiper motor, and once the bigger FETs get here, we'll be configuring the pendulum on the other balance beam, and so we'll be able to do a side-by-side comparison. And this whole process is turning out to be quite the learning experience. But it really doesn't take much to get the, if we get the oscillation going, we'll be able to should be able to drive some sort of PMA configuration at the output. So this is under manual operation, obviously, but that's just to demonstrate that the whole the concept works overall. It's just a matter of completion and testing. So thanks for watching. Enjoy the day. Waiting for parts. Cheers.